This video is the third one for section Seqr I. In this video we're looking at binomial expansions. Now, binomial expression contains two terms that are numbers, variables or combinations of both that are connected by an addition or subtraction sign. You see some examples here. The value of binomial expression squared, so x plus y all squared for example, can be determined by multiplications of terms using first principles, which we covered in quadratics module. Similarly, the expansion of x plus 3 or y, x plus y all cubed can be expanded in the same way. So let's see what I mean by that. Here you've got x plus y all squared, so that's going to be x plus y, which expands to be giving x squared plus xy plus y squared, which is x squared plus 2xy plus y squared. In quadratics you would have just gone from here to here. X plus y all cubed, x plus y, which is x plus y all squared. So I can just substitute what I had before. So that becomes x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. That then becomes x cubed plus 3x squared y plus 3x y squared plus y cubed. So we're just collecting like terms. So you can see that 2x squared y and that x squared y and the xy squared and the 2xy squared. Now, for higher powers than 3, the process of expanding binomials can become quite time-consuming and tedious. The binomial theorem enables the expansion of whole number powers of binomial expressions without this direct multiplication. Let's begin by looking at the relationship between binomial expansions and Pascal's triangle. When the expression x plus y to the power of n, where n is 0, 1, 2, 3, 4, and 5, etc., is expanded, you get the following result. And you can see that I've done that for powers of 1 from 0 through to 4. Now, the things to note. If you're looking at this x plus 1 to the power of 2, x plus y to the power of 2, you can see the coefficients. If you look at the x plus y to the power of 3, look at the coefficients. Next one, again, look at these coefficients. Then look at the relationship to Pascal's triangle. And you should see that those coefficients match Pascal's triangle. Another thing to look at is, as these x squared terms, if you look at the x squared, the power is decreasing and the y is increasing. So x cubed, x squared, x1, x to the 0, which is 1. Y to the 0, y to the 1, y squared, y cubed. Now, those details are in the textbook, so you can have a look at those if you need to. So let's use the properties of a binomial expansion to find the following. X plus y to the power of 7. Now, Pascal's triangle, we want the 7th row, which is 1, 7, 21, 35, 35, 21, 7 and 1. So I write out those numbers because that's they're the coefficients of my expansion. From there, I look at the first term, which is my x. Write that all the way along. And then the powers start at 7 and they decrease. Now look at the next term, which is the y. And I've got y all the way along. Now the powers increase. And then we just put plus signs in between our terms. Okay, neaten it up. Y to the 0 is just 1, so it's x to the 7 plus 7x to 6y plus 21x to the 5y squared plus 35x to the 4y cubed plus 35x cubed y to the 4 plus 21x squared y to the 5 plus 7x y to the 6 plus y to the 7. Much easier, I think you'll agree. Let's do one more. Okay, again to the power of 4, so my fourth row is 1, 4, 6, 4, 1. So I start by writing those coefficients out. So I might make a bit more room. Make sure you do use room so you're not going to get all muddled up. Start with my first term, which is 3a. Work my way along. Start with the highest power, which is 4, and decrease. Then do my next term, which is negative 2b. See what I mean by you needing space. Start at the lowest power and increase. Oops, 4. Okay, so from there, putting in the plus signs. And now we need to neaten it up. So 3 to the power of 4 is 81, a to the 4. And then I've got times, all of this to the power of 0 is just 1. Okay, move along, plus 4 times 3 cubed is 27, a cubed times, this would just be negative 2b. Keep going, 6 squared is 30, I have 6 times 3 squared is 9, a squared, times negative 2 all squared is 4, b squared, plus 4 times 3a times negative 2 to the power of 8 is negative 8, so it's negative 8b cubed, plus 1 times, all of this is 1, times negative 2 to the power of 4 is positive 16b to the 4. So that becomes 81a to the 4. 4 times 27 is 108, times negative 2 gives me minus 216, and I've got a cubed b. So I've done that. Now I look at this next part. 6 times 9 times 4 gives me positive 216, a squared b squared. Moving along to this bit. 4 times 3 times negative 8 gives me negative 96, ab cubed, and then my last term is plus 16b to the 4. Okay, what now? Exercise Seqr I3.